Hey everybody, Mr. Tannen here, just going to give you a quick video here to help explain some of these funky identities that especially come up in the textbook. So starting with just these reciprocal identities. Hopefully by now you can see, well, cosecant is the reciprocal of sine. So that's actually just how it's defined. Cotangent is the reciprocal of tangent, and secant is the derivative of cos. I remember it by being counterintuitive because the one with the s is actually derivative of the one that starts with c, and then the one with the c is not the derivative, the reciprocal of the one that starts with s. So hopefully you can start to get that, but you always could look into the book if you need to reference any of these identities. There's no problem with that whatsoever, because there are a bunch of them, and sometimes you really need to get you need to reference them. That's totally fine. Then we've got the tangent and cotangent identities. So if you think about it, well, tan is opposite over adjacent, and if we think about the unit circle, well, sine is opposite and cosine is adjacent. So that makes sense, and cotangent is just the reciprocal of that. So it's just those switch from previously. Hopefully that makes sense. Hopefully this first set of 5 identities is pretty straightforward. Then we get into the Pythagorean identities. Well, these ones all sort of come from this one, which is, we all know that in a right triangle, a squared plus b squared equals c squared. The sum of the squares of the two legs equals the square of the hypotenuse. Well, if we think about the unit circle, well, the unit circle is because the radius is 1, and let's say this is some angle theta, doesn't matter what it is. We know the vertical side is sine theta, and this horizontal measurement is cosine theta. So if we just, instead of using A, B, and C, we just use cosine, sine, and 1, we would get exactly this identity written over here. And we put the square here, that's just a notation device that tells us that it's not the theta squared, it's actually the sine of theta, whole thing squared. Same with the cos. So it really just comes straight from the Pythagorean theorem. And then all of these are just sort of, they're just takes off of that. So if we were to, divide everything and rearrange it, we could end up getting 1 plus the tan squared of theta equals the secant squared of theta. That would be if we divided everything by cos squared, then we would get a tan squared and a secant squared and a 1. And then this one is sort of similar. If we divided everything by sine squared, we would just end up with something. They all just sort of come, we would just end up with that. I could walk through that if people are interested, but I think just understanding these identities and using some reference as you're working through this will be most helpful. We've got these cofunction identities, which basically is saying sine, if we have like pi over 2 radians or 90 degrees minus the theta, that's going to give us the cos of that same theta. Same with the tan of pi over 2 minus theta. That's going to give us the cotangent of whatever that theta is. I believe this is a typo here. Wow. The cosine of this pi over 2 minus theta is going to equal sine theta. So these are all quite similar to one another, but that shows you why we can do, some of these horizontal transformations and end up with the same thing, exact same function, just with a different, like for instance, we could write a sine function as in terms of cosine and vice versa. Negative angle identities, well, if it's negative theta, it's just going to be the negative vertical measurement, so it's at negative sine. However, for cosine, if we take the cosine of negative theta, let's say we have this is theta, but instead we do negative theta, well, it's still the same x measurement, right? So that's why cos of negative theta is still equal to cos of theta. But then for tangent, because only one of the two is affected, if we make the angle negative, well, the tangent also switches signs. Hope that helps somewhat there. Uh-oh. Ooh, then we got these sum and distance formulas. Let's see if I could erase. Ooh, no. Let me bring it right back here. We've got these sum and difference formulas. And these are really, these are really quite brain-boggling sometimes. So I would really reference the textbook. Page 520 has them all on there as you're working through this. But you're going to really go over this quite a bit in pre-calc, but it really does start bubbling your brain when you start looking at all these sine and cosines, A's and B's. But the nice thing is, and I would say the one thing is, it can really show you how you can get an exact measurement for the sine or cosine measurements or tangent measurements for angles that are not 30, 45, 60 degrees, 90 degrees, or multiples of 30, 45, multiples of 30 or 45 degrees. Like, you'll see that in example 1. It allows you to express, find the exact value of some of these, sine or cosine values without having to always just plug it in the calculator. But it's just real heavy algebra on this one. But feel free to reference these things. Let me know if you have questions. Please use a calculator if necessary. But hopefully these don't end up being too wild for you. Let me know if you have any questions. Yeah, I think hopefully the questions I assigned there, I think it's only 6 or so. You'll be able to work through those, given that you got the week for them. But yeah, I know this is really the end of the trig stuff. They really start throwing some real formulas at you. But let me know if you have questions. And like I said, please reference the textbooks. These ones are, if you're doing the textbook work, I almost started to recommend the Khan Academy because I think at the distance it's nice having those videos. These ones are on page 520. And then the other ones that we looked at, they're all on page 514. So those 2 pages will be quite helpful for you all in working this stuff out. Hope everybody's doing well. Much love to you all. See you all soon.